Hi class, this is Unit 4 Review, Part 2. We needed to answer one more question from Video 1 that we were talking about. Is this formula valid in the case described? And the answer is yes, because the approximate half-life rule, the 70 divided by p, works for any percentage that's under 15%. So this one was 6%, which is under 15%, so it worked. All right. Next up, we're going to do number 9. I believe, yep, 9. So use an annual growth rate of 0.6% in a 40-year period for a certain population to find the approximate doubling time, and then predict the population in 2050 based on a 2000 population of 5 billion. All right, so we have a couple of things to do. First of all, we need to find the approximate doubling time. So approximate doubling time is 70 divided by that 0.6%, whatever the percent is. All right, so that's the approximate doubling time. Now I'm going to just clear out my calculator here and do these so that I have them on my calculator as we go, because I want to hurry and figure them out before we move on. So anyway, we got approximately, round to the nearest whole number, it's 116.666, so we'll just do 117 years. All right, and then the next part says predict the population in 2050. So 2050 is 50 years after 2000. So you would just take 2050 and subtract 2000 to get little t, and that's 50 years is little time. And then initial population is 5 billion. All right, so 5 billion. So we take our initial population of 5 billion, and we multiply it by 1/2, which I like to write 0.5, as you know, to the little t over doubling time, 117 years. All right, and 5 parenthesis 0.5, and then 50 divided by 117 is my exponent, and I got approximately 3.7 billion. But it's going to want 4. It's going to want you to round to 4 billion years. So doubling time was 117 years, and then the population, the new population, is about 4 billion. So let's see if I can remember that I'm actually typing in the half time first, right? So 117. And then the next question is, what's your population nearest 10th? 3.7. All right, it's going to be the population after 100 and I'm so good at this. What did I do wrong this time? Oh, you know what? I bet it's because I rounded to 117 when I put it in my calculator again. It's obnoxious. Calculate problems again. If I do it in class, then I'm going to have you see if I can find my calculator here. So I rounded to 117 when I put it in my calculator. So I'm going to go up and I'm going to extract it. And then I'm going to go over and I'm going to change. I'm going to delete out that number. And then I'm going to go up and extract the more more exact, I guess, more exact number. Oh, I still got 3.7, didn't I? Well, that wasn't the problem. Let's figure out what the problem is. I'm sorry, this is like taking a while. I probably should have done these problems beforehand, but I didn't really want to. I don't know what I did wrong. Maybe you do. Let me pause for a second. All right, you guys are probably shouting at me. I used half-life, not doubling time, which is so crazy. Delete. This is why I need Deidre here to tell me what I do. It's not half-life, we're doubling the time, right? Doubling time. So 6.7. All right, well, it just took me a second. I knew it as soon as I looked in my parentheses in my calculator. Sorry. Okay, if I have to be careful that when I'm doing half time, I'm dealing with 1/2, and when I'm doubling, I'm dealing with the power of 2 doubling time. All right, what's next? Number 10? All right, this one's an easy one. I should be able to do it. Okay, the following table gives the birth and death rates for 4 countries in 3 different years. Find the net growth rate due to births and deaths in each of the 3 years for country A. And then, based on these trends, predict how the country's population will change in the next 20 years. All right, so you're just going to be dealing with country A here, so I can highlight these are the numbers. And remember that growth rate is birth rate minus death rate. So growth rate equals birth rate minus death rate, right? So 14.7 minus 11.8 is going to be 1985. And then 1995 will be the birth rate, 10.6, subtract 11.6, the death rate. And then 2003 will be 9.8 minus 11.1. All right. Now, I'm just going to place those all in my calculator really quickly. And I better just check to make sure everything's right. But if I put those in my calculator, let me see if the ImageMate will show up here. Maybe you guys can, I don't know what happened to my, I don't know what happened to it. Anyway, 10.6 minus 11.6. And then 9.8 minus 11.1. I was going to, but it didn't let me. Something must happen. So 2.9 per 1,000 is what I got first. I'm not checking these, and I do not have Deidre here to tell me what they are. But I hope I don't embarrass myself again. So -1, when I subtracted, and then the last one was -1.3 per 1,000. Okay. So then it says, will it increase or decrease? Well, based on our numbers, and we have to go back scrolling through and check on them. We had a 2.9, which was quite a bit of growth the first up to 1985. 1995, we had a -1, so it was a drop in growth rate, and then a -1.3, another drop. So it's decreasing, isn't it? So population will be decreasing. All right. What are we doing next? That one was 10. So we need to do number 12. Checking on my time. In the following situation, state whether 2 variables are related in a way that might be described by a function. If so, identify the independent and dependent variables. So if you make a list of your 5 friends' families' names and all 17 of their email addresses. Oh, that's crazy. A list of 5 friends' families' names and all 17 of their email addresses. Boy, can this situation be described as a function? I have to think about it. So it's names and email addresses. All right. The independent, I don't know. This one is a really crazy one, and you don't have actually one like this on the test. And I'm a little bit nervous to actually answer it because email addresses, I don't know. Sometimes your email addresses are based on your names and some of them are not. So it kind of depends on the situation. Dependent variable, or I would say it cannot be described just because very few of the people I know actually use their names in their email addresses. And I was right. But then I kind of got worried that maybe they might decide that they do use them. I don't know. Oh, lucky. All right, 14. Write a short statement that expresses a possible relationship between the variables. So travel time from Denver to Chicago and then average speed of the car. So with number 14 here, does the travel time and the speed of the car, the travel time is going to be independent, and then average speed of the car will be dependent. And we would say as the average speed of the car increases, the time to drive decreases, right? So as the average speed of the car, the faster you go, the less time it takes to actually drive because your rate's going to increase. All right. Next one is this one, number 15. So consider the graph of the function below. Identify the independent and dependent variables and describe the domain of range. No, you don't really have to write anything down. You just have to look at the graph. So when you're looking at the graph along the bottom, you see years, and that will always be along the x-axis, the independent variable. So those are years. So independence along the x and the dependent is along the y. Dependent is population. Independent is year, dependent is population. All right, and the next question is what's the domain? So the domain is going to be the years because it's independent. Oh, and then we need to look at when the first year is 1950. So 1950, and then the maximum is 2000, I thought, right? Yep, 2000. So it's where the graph ends there on the year 2000. And then the range, that's your population along here. And we start round to the nearest integer. So this is very close to 2, and this is very close to 6. So let's go with 2. With 2 billion, and then to 6 billion. Silly thing that I had to use the palette once, and it keeps throwing it in my way. All right, choose the correct description below. So we're seeing a pretty steady increase, aren't we, if we start at the year 1950 and then head up to the year 2000. So with that steady increase, it shows a steady increase in the population from the years 1950 to 2000 is what I'm guessing it is. Yep, all right. And then the next one we're going to do is 17. So the following situation involves a rate of change that is constant. Write a statement that describes how one variable changes with respect to the other and give the rate of change numerically with units and use the rate of change rule to answer the question. So if you run along a path at a constant speed of 2.5 miles per hour, how far do you travel in 1.7 hours and in 3.5 hours? So if you're running along the path at 2.5 miles per hour, the first thing you're going to notice is that the distance traveled varies with respect to time. So A and D are good. At the change of 2.5 miles per hour. So you have to be careful because this one has the miles per hour change. It says hours per mile. So watch that. Make sure that you get the units right. And then the next one is after 1.7 miles. So after 1.7 miles, you're just going to take the 2.5 times 1.7. I don't want to spend the time moving over because I'm kind of running out of time here. 2.5 times 1.7 is 4.25 miles. And of course it says type in integer or a decimal. And it doesn't give us anything else than that. So that's 4.25 and then 3.5. We're going to again times it by our speed, 1.7. So 1.7 times 3.5 hours. And that's 5.95 miles. So you can figure out, oh, dang it, I did it again. I times 1.7, I meant 2.5. 2.5 times 3.5. 8.75, Miss Juliana. Maybe I ought to wait till tomorrow to do the next ones. Get my calculator skills back on track. Have enough time for one more? Okay, so the cost of leasing a car is $1,000 for the down payment and processing fee plus $320 per month. How many months can you lease the car with $3,230? You know what? I'm going to stop the video because it's going to take more than the time that I have. So I will save this and then we'll do round 2 in a minute.